I'm Brad from the Go team, and I'm going to be talking about testing. And you're like, oh, I already know how to write tests. You have your little function, you write a little test thing, and you like print things out in the right order. You're like, please, Brad, I'm a professional Gopher. I write table-driven tests. I test all my boundary cases. Cool, gold star. You know everything. But what if your little pure function has some side effects? How do you test that? Well, you're like, please, Brad, I'm a professional Gopher. I pull out all my side effects, and I like inject them so I can like test those separately. Cool, gold star. You win. But what if you have like a crap ton of side effects? And you're like, please, Brad, I'm a cloud-native Gopher. I'm going to put that in a container. I'm going to put that in Docker. But what if that isn't enough? OK, story time. I built a little crappy data center in my garage, and I run a bunch of VMs on it. And my VM template is this little 5 gig thing for reasons. And I needed to like enlarge these disks, so I wrote this tool called embiggen disk. And you're like, embiggen disk? What is that? It's a perfectly cromulent word. So anyway, I have these little 5 gig disks, and then there's the partition table, whether it's MBR-GPT, and if you're using LVM, then you have your like physical volume on that, and then you have your volume group, and then finally you have your file system, and then you write some big old file to it, and you fill it up, and you're like, crap, my disk is full. So then you go to your cloud provider and you say, make my disk bigger, or you tell Proxmox or KVM or whatever, QEMU, to make your disk bigger. And what it does is takes this part and makes that bigger. And it's like, Linux is like, great, block device got bigger. Your cloud provider's like, mission accomplished. But then you're like, it's still 93% full. And LS block is like, well, here's all your space, not doing anything, and you have all these other layers. So I wanted to just say embiggen disk and like do all that crap, like rewrite the partition tables and the ioctls to the kernel to like resize it. And the problem is there's not a great tool to do this. There's lots of Stack Overflow snippets that are terrible, and there's tools that don't use ioctls that were added to Linux like 6 years ago. So anyway, how do I test this tool? I have to be better than Stack Overflow. I need tests. And I'm like everything here requires root. So I don't know how I'm going to test this. How do we fake a disk changing size during the middle of our test? We could like fake out everything and pretend that a disk changes size and pretend a partition table, but this is tedious and it gives us a false sense of security. We really need an integration test, which means we're going to need a VM. So where are we going to use a VM? We're going to use the cloud? No, the cloud is too slow. We're not going to wait minutes or even 30 seconds to like start a VM. It's too expensive. We want our contributors to be able to like run this too. They don't need credentials. We don't want to have them have credentials to run the tests. So GoTest should be both fast for me and for my users. So I'm going to use QEMU. And we're going to boot the Linux kernel every time we run GoTest. And also, QEMU has an API, so we can do things like add and remove disks at runtime and change their size. So I'm going to write a little function, test QEMU, in QEMU. And in a nutshell, we're just going to run QEMU system, and we give it a bunch of stuff to like, no graphics. We're going to tunnel in a port of the QEMU API server so we can control QEMU from within our test. But the main thing is QEMU lets you boot a Linux kernel and initrd directly without going through the BIOS, which is slow, and grub, which is slow. So we need a kernel and initrd. The kernel is just a few meg. You could use the host kernel, but I wanted to have a super minimal one that booted really quickly and only had the minimum stuff I needed. So I just built this once, and I shoved it in Git in my normal GitHub repo. And I don't want normal people using my thing to run this. So I put in a weird old ref so people running go git won't fetch it. But then at runtime, when I run go test, I just git fetch this weird ref, and then git cat file the blob that holds the Linux kernel image and write that to disk. OK, so what initrd should we use? When the Linux kernel boots, it starts an init process, and then that loads up your user space. So which distro are we going to use? Which init system? Are we going to use Arch? Maybe Debian? System, the classic init? Are we going to use systemd? Who likes systemd? Nope, we're not going to use any of this. No. We're going to use Go. Just Go. No user space, no init, just Go. So what we're going to do is take the Go test's own executable that we're running and copy it into the initrd, and we're going to build a user space dynamically. So we're going to generate the CPIO archive, and the init process is going to be us. And then so what we do is we also generate some like dummy mount points that we're going to use in our tests, and we need like proc consistent dev mounted. And we're also going to put in some tools we need. Like we need a ls block for testing and make 2fs to make a file system. But we also need all their dependencies. So we copy in the libc dependencies, we copy in, and then we call LDD to figure out the C dependencies of these tools, copy those in. And then when our test starts, we check to see if we're PID1. If we're running as a init, we say hello from user space. We mount sys, proc, and dev, which things are going to need. And then we copy in from the kernel command line things like the test.v and test.run flag. So when you run go test.v.run, it sends it to the Linux kernel, and then we extract it back out there, and we put it back in the flag. So now I could set a test main. And then when it runs, I could connect to the QEMU API server and shut down the VM properly rather than letting my init process end and then having a kernel panic. And now, at the end, I run go test-v. It gets plumbed through. You see the Linux kernel boot. 1.6 seconds later, I'm in user space. This is pure emulation, no KVM, no root. So anybody can run this. And then I write my little tests that have testing.t, and now I have this monc, this monitor client that talks to the QEMU API. I could add disks, remove disks. I could make partitions. And then 15 seconds later, I have my test results, and it all works. Mission accomplished. Thank you.